I talked earlier about our mission at GitHub, to be the home for all developers. And we know that developers want choice. Who doesn't? We're committed to delivering on this and ensuring that every part of your development lifecycle is swappable when you're using GitHub. This includes CI providers, security solutions, cloud platforms, and more. Actions takes this to heart. You can automate anything, replace any part of your workflow, and integrate easily with other tools. On that note, I'd like to invite Claire, a principal engineer from Amazon Web Services, to the stage to show us an awesome code-to-cloud workflow that they've built. Welcome, Claire.
Hi, I'm Claire Ligori. I'm a principal engineer on the AWS Containers team, and I'm a big fan of containers. I love that containers can help us to share our applications with others, and I love that containers can help us to deploy our applications to the cloud. I like that there's this easy, standardized way to describe how to build my application for a container with all the dependencies built right into the container image. I like that when I share that image with you, I don't have to make any assumptions about what Linux flavor you're running or libraries you have installed. I can simply share this image with you. And then it's as easy as Docker pull and Docker run for you to have my super cool application running on your laptop. So it's that easy. And then when you get to the cloud, now you can scale out to multiple copies of your application running in containers for high scale. You can scale out to multiple applications across many different containers. But you start to need something to manage all of these containers for you, to help you deploy and scale and keep them running all the time. At AWS, we have a broad portfolio of services to help you run your containers in the cloud. The Elastic Container Registry, ECR, will help you to store your container images and share those applications with others. We have 2 services to help you manage and deploy and scale containers: the Elastic Kubernetes Service, EKS, for your Kubernetes workloads, and the Elastic Container Service, ECS. We have 2 options for ECS for where your containers run: EC2 and Fargate. So for example, if you use ECS to deploy and manage your containers, you can create a resource called a service, where you tell ECS, I want to run 15 copies of my application all the time. ECS will keep those containers running. And you can give 3 EC2 instances to ECS to run those containers. Or you can take advantage of Fargate. Fargate is serverless compute for your containers. So you can tell ECS, I still want to run 15 copies of my application, but I want to use Fargate. So you don't have to have any EC2 instances to scale or manage or patch those instances. You can simply focus on building your applications, packaging them into containers, and deploying them to the cloud without worrying about the underlying compute for those containers. I specifically focus on developer tooling for ECS and Fargate, so I'm super excited to be here today talking about GitHub Actions for ECS, Fargate, and ECR. I think that GitHub Actions can help us to smooth the way to getting our code into the cloud. I think a lot in my day-to-day life about what are those little frustrations we have as developers every day? What are those things that slow us down from getting our code into the cloud? And I think about what are the integrations that we can create for ECS to help make that a smooth process. So today, I'm really excited to announce that AWS and GitHub have collaborated on a set of 4 GitHub Actions that are in the GitHub Marketplace today. So in order to show you these 4 actions, I'm going to take you through a sample day in the life of a developer who's using ECS, Fargate, ECR, and these GitHub Actions. So to do that, I'm going to use mythicalmisfits.com. This is an online adoption agency for mythical creatures. You can select different characteristics to find your favorite mythical creature, and then view their profile to find out more information about them. I happen to like Coco the dragon quite a bit. I think she's pretty cute. So I'm going to go ahead and hit this like button, this little heart. So this is a containerized application with multiple microservices behind it. So I have a like microservice. So this is generating the API that's driving that heart button, that like button. So we can go ahead and try it out. And I'll paste in the ID for Coco the dragon. She's pretty cute. So now Coco has 2 likes. So as I said, this is a containerized application. This microservice is running on ECS and Fargate. ECS is keeping 3 copies of my application running at all times, and it's running on Fargate. So if I go over to the EC2 console, I have no instances running. I can simply focus on deploying my applications in containers and not on those instances. Here's my Docker file. So this is such an easy way for me to specify, here are my Python dependencies, here's my Python code, do a little bit of linting in there to make sure my style is good, and then here's the command to actually run that. And then this is the actual Python Flask code that's driving that API. But one of the things, we have a problem here, there's no unlike API. I can't actually unselect that heart if I decide I don't like Coco anymore. So I'm going to go ahead and build that today and push that out to my application. So the first thing I do on my laptop, I run Docker build. I got to get my workspace set up. But it looks like the build is broken. Looks like some linting rules have failed. So I'm going to go ahead and see who actually broke the build. Who on my team broke it? And it's Coco the dragon. That's weird. What is she doing in my Git repository? She says, I tested this locally on my laptop, so it totally works, I promise. And haven't we all heard that from our teammates and maybe from ourselves at one point or another? So I think this is one of those first things that slows us down day to day as developers from getting our code into the cloud. So I'm going to automate this away with GitHub Actions. So the first thing I do is I have this check workflow. On every pull request, it's just going to run Docker build. This is such an easy way for me to make sure that that build is never broken and I don't get slowed down by my other teammates. So to see this in action, I have my unlike API ready to go. It's in a pull request. My teammates can review this code in GitHub. I've written that unlike API in my Python Flask application. And then my teammates can see that the checks have passed, and they've seen that my custom GitHub action check has run successfully, and it's ran that Docker build command. So this is the same thing that I could do for any containerized application that I stored in a GitHub repository. I can have that really simple check run every time there's a pull request. So now we've seen that it's successfully built. Now I need to deploy. Now is the second time where I have something slowing me down from getting my code into the cloud. What we're looking at here is a task definition file for ECS. This is basically the configuration I need to give to ECS to run my container. Things like, what image do I want to run? What environment variables do I want to set? But the image ID changes every time. I have a unique image ID that I need to go and fill into this file. Then I need to deploy this file to ECS. So this is a multi-stage process. It's kind of manual. It's error-prone. I don't really like to do it. I just want to focus on writing my code. So I'm going to, again, automate this away with GitHub Actions. So this is using those 4 actions that AWS has published today. This is going to run on every push to the master branch. First thing that happens is it's checking out my source code that just got pushed to the master branch. Next is the first GitHub action we've published today, configure AWS credentials. This is taking AWS credentials that I've stored in GitHub Actions secrets and configuring the environment so that other actions can use them. Next, I'm logging into ECR. This is where I'm storing my container images. Next, I'm going to go build and push that image into ECR. So the tag for this image is going to be the commit ID, and it's going to push it into the registry that came out of that login ECR action. So this is pretty much what you would do for any containerized application, Docker build and Docker push with this unique ID. And then I need to take that ID and fill it into the task definition. So this is the third action that we've published, render task definition. It's going to take that unique image ID that was generated from the commit ID and fill it into my task definition for me, replacing that to-do fill-in string. And then last but not least, the fourth action, deploy task definition. So this is going to take that file, deploy my image and the configuration around it to ECS, and wait for that deployment to be successful. So let's look at it in action. I'm going to merge in my unlike API pull request. And because I'm merging into master, that's actually going to kick off automatically my deploy action here. So as soon as I push into my repository, I can see that this deployment is in progress. And we're quickly going through checking out the code, configuring those AWS credentials, logging into ECR, and we're on to the build for the Docker image. So it's pulling in all of my Python dependencies, copying in all of my Python code, running linting, and then finally it's going to push into ECR. So at this point, I could share this application with others, and now I'm going to deploy this application to the cloud. So now that I have this unique image ID with that commit ID for the commit, it's filled it into my task definition automatically, and now my deployment is in progress. So looking on the ECS console, we can watch this deployment in progress. So I've told ECS I want 3 copies of my application. So I now have 3 copies of the old and 3 copies of the new while the deployment is in progress. And then we can go and we can look at the Events tab and actually watch what's happening under the hood. So one of the things we'll see is those new containers have been started up, and they're being added to the load balancer. So anyone who's going to Mythical Misfits right now is actually able to see the unlike API in action. And then it's going to start deregistering the old version that doesn't have the unlike API from the load balancer. And it's going to drain connections first so that we don't have any more requests going to those tasks. And then finally, it's going to have shut down all of the old containers. And so now what we see is that we now are back to only 3 copies of the application, all running that new version of the application. So then when we go back to the GitHub action, we can see that this deployment is successful, and it waited for it to be successful in ECS. And so right in my GitHub repository, I can see that I've now deployed successfully to the cloud. So we can try out this unlike API. I'm going to again paste in the ID for Coco the Dragon. She broke the build. It's an unlike for me for Coco the Dragon today. And so now she's back down to 1 like. So I encourage you to check out mythicalmisfits.com for an online workshop to get started with ECS and Fargate. And you can check out in the GitHub Actions tab in your GitHub repository today, you can see the Deploy to Amazon ECS starter workflow to help you get started continuously deploying to ECS and Fargate. So thank you so much for having me today, and I'm going to hand it over to Erica.